Uh, Already in the previous class, we were with the introduction of the matrix. Matrix means an rectangular array of numbers. Matrix is an rectangular array of numbers where if we have m number of rows and m number of columns, then we say the matrix is of order m cross n. The term that is order of m cross n. How many elements? Now there are now the number of elements must be m cross n. Now when we are defining any matrix, it's look like with the parenthesis or the bracket. That means we are using the parenthesis or the bracket. Now in short form, we may write according to the element. Suppose element a, I, j. Already we said that the I is representing the position of the element in which row, and j is representing the position of the element in which column. Now suppose in that matrix it has m number of rows and n number of columns, then the matrix is of order m cross n. So we may also write in short form like that, a, I, j using parenthesis m cross n. Or suppose we have another matrix and we are denoting the matrix with the element like bij. It also has m cross n order. So also we can write it in that way. That is the short form of a matrix representation. Or we can write according to the rectangular array, that means A11, A12, A13 in that way using parentheses and bracket. Next one, whenever we are proceeding with any type of matrix, at least one element must be there, at least one. It may be anything, but at least A11 must be there. So suppose if we have any order A11, A12, A13, A21, A22, A23. Okay, that is of order 1 cross 1, that is of order 2 cross 3. That particular first element, that means A11, is called the leading element. That means A11 is called the leading element. That is the first one thing. Okay. Next one. When we are proceeding with the matrices, there must be some different type of matrices also there. The very first one is called the row matrix. Another one is called the column matrix. Row matrix, that name also suggests that it has only one row. The matrix which has only one row is called a row matrix. Same as when in a matrix only one column is present. Whatever be the number of rows, only one column is there. That matrix is called a column matrix. Let us take an example like that. Suppose A11, A12, A13, A14. Now, if we look at the matrix, only row is 1. Ektai matro row. Then, number of columns are column 1, column 2, column 3, column 4. So we can say the order of the matrix as 1 cross 4. That means M is equal to 1, N is equal to 4. That type of matrix, only one row present, whatever be the number of column, is called a row matrix. Same as if we have a matrix A11, A21, A31, A41. Now, how many number of rows are there? Row 1, row 2, row 3, row 4. But how many number of columns are there? Now, only 1. So that type of matrix order is 4 cross 1. So that means N is equal to 1, but M is equal to 4. That type of matrix is called a column matrix. Now, when we are giving the name row matrix and column matrix, these two matrices also have some different name. Row matrix is also called a vector. Row matrix is also called a vector, and column matrix is also called a tuple or tuple. Sometimes it is pronounced as tuple. Most of the cases it is pronounced as tuple. Now the second one. Suppose we have a matrix A11, A12, A13, A21, A22, A23. So that is of a matrix of order 2 cross 3. 2 rows, 3 columns. Then we may consider the first row as a row matrix or the second row as a row matrix. Same as also we can say that
Sir,
say
please tell me what is the meaning of tuple?
I am proceeding. Okay.
Okay, sir.
Now, when we are considering any matrix, the first row is only a single row. How many columns are there? So that yellow colored mark is containing only one row and 3 columns. So that is also be considered as a row matrix, or that is a vector. Second one, once again, the second row is representing only one row and 3 columns are there. So the second one is also called a vector. Now, according to the column, if we proceed to another one, suppose the first column, that means the first column is here, that is representing A11, A21. So how many rows are there? Now row 1, row 2. But how many columns are there? There is column 1. That means only one column. So that matrix is also called a column matrix. And its different name is the tuple. That means row matrix is also called as a vector. Column matrix is also called as a tuple. So in the same way, we may say that the second one is also another tuple. The third one is also, third column is also another tuple. Is that clear?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So okay, the first two terms are row matrix and column matrix. Then the second term, that is called the square matrix. Very important. When we are proceeding with the name, that is called rectangular matrix. What is the meaning of rectangular? Now, according to geometrical shape, a rectangle looks like that. Okay, where we have breadth, we have length. Most of the cases, breadth and length are different. So when we are proceeding with the rectangular matrix, that means the order m cross n, m is not equal to n. Suppose 2 cross 3, suppose 3 cross 2. So both are different. So it's look like, suppose I am proceeding with the 2 cross 3 at first. So A11, A12, A13, A21, A22, A23. If we draw something that's look like a rectangle, so that's why it is also called a rectangular matrix. Or another way, suppose 3 cross 2, A11, A12, A21, A22, A31, A32. Once again, that type of matrix looks like a rectangle. That's why it is also a rectangular matrix. But what is the case of square matrix? Square matrix is that one. That means where m is equal to 1. That means when we draw a square, all the lengths are equal. That means breadth is equal to length. So here m is equal to n. That means 2 is equal to 2 or 3 is equal to 3. Like that. That means the order must be m cross n, can be written as m cross n or n cross n. 2 cross 2, 3 cross 3, 4 cross 4, like that. Let's check. Suppose we have 3 cross 3, a matrix. Okay. A11, A12, A13, A21, A22, A23, A31, A32, A33. Practically the draw is not perfect, but if we check that, that must be a square form. Okay, so that means when we have a matrix whose row is equal to the column, then we must say that matrix as a square matrix. Row matrix itself is a rectangular matrix. Column matrix itself is a rectangular matrix. But not always that is true. Why I am saying? Suppose the very first one, when we have a square matrix, normally any rectangular matrix is called like that, a matrix with order 2 cross 3, 3 cross 2, 10 cross 5, suppose 4 cross 1, like that. So that is the case of the rectangular. In the case of square matrix, we must say square matrix of order m or n or 3 or 2. Only one number is sufficient because m is equal to n. n is equal to m. So whatever be the, suppose that is 3 cross 3. So here we can say that one is a square matrix of order 3. Jehetu that is 3 cross 3. Okay. Next one, suppose another one. We have a matrix that is A11. Only one element is there, and that one is the leading element. So whatever is the order of that matrix, that is 1 cross 1. Because here m is equal to n, we must say that one as a square matrix. Now look at the thing. A11, only one row is present here. Okay, only one row. So as only one row is present, what is the number of the column is not considered. So we must say that one as a vector. Once again, that one is a matrix with order 1 cross n. So only one column is there. So that must be also called as a tuple or column matrix. But as that is a row matrix or vector or column matrix or tuple, but it is also a square matrix. So not each and every row matrix or column matrix must be a rectangular matrix. It may also happen with that it may be vector or a tuple also. Okay. So first one is the row matrix, second one is the column matrix, third one is the rectangular matrix, fourth one is the square matrix. Now after square matrix, another term of the matrix is there, and that one is called the diagonal matrix. Okay, and for any diagonal matrix, it has to be a square matrix. That means any diagonal matrix, at first it must be a square matrix, then it must be a diagonal matrix. Let's check what is a diagonal. When we are proceeding with any rectangle, from the corner points to the opposite corner points and that point to that point are originally the diagonals. But in the case of rectangular matrix, no diagonals are considered. So that is not the case of rectangular matrix. Suppose we have a square. According to geometry, what is the diagonal? What are the diagonals? Now from that point to that point. But here also, only that elements which are present from the leading element to the last element are considered as diagonal. Let's check why. Suppose we have a matrix like that. A11, A12, A13, A21, A22, A23, A31, A32, A33. Which are the diagonals? Now, diagonals elements means Aij, where I is equal to Z. I is giving the position of the element in which row, J is giving the position of the element in which column. So that means it must be, if in the first row and first column, so A11 or A22 or A33 or A44, like that. That means that one is the only diagonal elements. Those are only the diagonal elements. So according to the condition, suppose another one, 1, 2, 3, 4, 5, 6, 7, 8, 9. So obviously that one is a square matrix because 3 cross 3. So that is a square matrix. Very good. Then we are considering the diagonals. According to the position, if we check, 1 1 means A11, 5 means A22, 9 means A33. I is equal to J. So those are called 1, 5, 9 are called also as the principal diagonals. Not only diagonals, those elements, diagonal elements, are also called the principal diagonals. So, two part already. First one, rectangular. Rectangular 2, if m is equal to n, we are getting square matrix. Now, from square matrix, At that moment, we are yet not proceed with the diagonal matrix. Which one is a diagonal matrix? Diagonal matrix means all the off diagonals are equal to 0 or not present. Why not present? That would be a different thing. Equal to 0. So if we check that matrix at first, the principal diagonals are 1, 5, 9. But off diagonal means that one is an off diagonal, that one is an off diagonal, that one is an off diagonal, off diagonal, off diagonal, off diagonal. So these elements have to be equal to 0. So now if we consider that one, 1, 2, 3, those are the principal diagonals, and all the other like off diagonals are equal to 0. So if we say those are the principal diagonals, then that matrix itself is a square matrix. Then it one is also a diagonal matrix because all the off diagonals elements are equal to 0. So from square matrix, we can find out the diagonal elements. Next, the question can arise. If all the elements are 0, suppose that is a square matrix. If the diagonals are also 0, can we say it as a diagonal element? No. Diagonal matrix? No. Because diagonal matrix is represented for the calculation where we have some values with the diagonals. So that one must not be considered as a diagonal. That is a square matrix because we have 2 cross 2. But yet now the diagonals are not equal to any other value except 0. So that is not a diagonal matrix, that is a square matrix. Any other one question, suppose we have another one matrix like that, 1, 2, 3, 0, 0, 0, 0, 0, -1. So according to that, the diagonal elements have some values. Off diagonal 0, 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 but that one is not an off diagonal, which is equal to 0. So we must consider it as a square matrix only, but that one is not a diagonal matrix. Is that clear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Next one.
Yes, sir.
Yes,
Sir.
Next one, off diagonals are equal to 0. That is true or not present. Why? Not present means suppose we have a matrix that has only one element, the leading element, and it is a square matrix, 1 cross 1. Now look, that one is a row matrix. That one is a column matrix. That one is a square matrix as m is equal to n or 1 is equal to 1. Now, all the other, so it also is a diagonal matrix because the diagonal element is the leading element only 1. It is also called a diagonal element because in the case of diagonal matrix, all the off diagonals are equal to 0 or not present. So if we consider only that one, like, so here the diagonal we are getting, so it is a diagonal matrix. Off diagonals are not present, that does not matter. So that is also a diagonal matrix because it is also a square matrix. Okay. So from diagonal matrix, we are proceeding another one. That one is called the scalar matrix. Scalar matrix has to be number 1 must be a square, number 2 must be a diagonal matrix. That means for any scalar matrix, it has to be a square matrix and it has to be a diagonal matrix. Let's check with an example. And what is the third condition? That is the identity of the scalar matrix. Suppose we are writing 2, 3, 4. Okay, 0, 0, 0, 0, 0, 0. That is square, that is diagonal, but that is not a scalar. A scalar means all the principal diagonals having the same value. Having the same value.
Sir, full screen is not visible.
Having the same value.
Sir,
Surajit, I am muting you. That's why it may be not in the full screen. Okay. Now is that right? Okay. Now is it full screen?
no, sir.
Any
Right
other
side
one?
screen is not visible.
Any other one? Maybe your network problem.
Sir, zoom
Yes,
করে
sir,
ফেলেছে হয়তো।
No Zoom. Practically, I was just maximizing your participant list. That's why that part was the black. Nothing problem. Maybe your network problem, it has not been synchronized yet. Any other one? Now check that. Okay, wait for some time, it may be. Scalar matrix, that one is not a scalar matrix. All the principal diagonals having the same value. Now check here. Suppose we have a matrix 3, 3, 3, 0, 0, 0, 0, 0, 0. Now, if we consider, look at the thing. Number 1, 3 cross 3, m is equal to n. So it is a square matrix. Then the second one condition that the off diagonals are 0. The off diagonals are 0. So obviously it is a diagonal matrix. And third one, from the diagonal matrix, all the principal diagonals have some same value. Principal diagonals have the same value, that is 3. So it may also be considered as a scalar matrix. Okay. So next one, suppose we have another one problem. Just giving you some example with 3 matrices. The first one, 1, 2, 3, 4, 5, 6, 7, 8, 9. The first one is a 3 cross 3. So it is only a square matrix. 1, 2, 3. So it is 0, 0, 0, 0, 0, 0. So it is a square matrix. Moreover, it is a diagonal matrix. 1 1 1 0 0 0 0 0 0. So it is 3 cross 3. It is a square matrix. It's a diagonal matrix. Moreover, all the values of the diagonals are principal diagonals are equal to 1. That means same. So it is also a scalar matrix. Is that clear now?
Yes, sir.
Yes,
sir.
sir.
Yes, sir.
Sir.
Now, from the scalar matrix, acha, first one question. Attendance পাঠিয়ে দিয়েছিস রে কেউ?
হ্যাঁ স্যার পাঠিয়ে দিচ্ছি
হ্যাঁ
স্যার
স্যার
একটু
তুলে
পরে।
রেখেছি
ঠিক আছে, ওকে।
স্যার
তোলা
তুলে
হয়ে
রেখেছি
গেছে।
তুলে রেখেছি
আচ্ছা, আমি এর মধ্যে আর বলছি না কিছু। যদি কেটে যায় আমি করতে করতে থাকবো, যদি কেটে যায় আবার সেম লিংকে জয়েন করে নিস। হ্যাঁ, কারণ ফ্লো
ওকে স্যার।
ঠিক আছে
করতে পাবো না, টাইমটা অলরেডি 10 মিনিট বলে দিয়েছে।
ওকে স্যার।
Next one term is called the zero matrix or null matrix. Zero matrix or null matrix, and it is denoted by capital O or zero or big O, also called it. Okay, so what is zero matrix or null matrix? Now it may be a square matrix. Moreover, it may be a rectangular matrix also. But all the elements in the matrix, whatever be it is rectangular or square, are zero. That means suppose we have a matrix 0 0 0 0 0 0 0 0. That means 2 cross 4. It is a rectangular matrix, but all the elements are zero. So it is called a null matrix. Suppose another one 0 0 0 0 0 0. So it is of order 3 cross 2, but all the elements are zero. It is called a null matrix. Or 0 0 0 0 0 0 0 0 0. It is a square matrix of order 3, but all the elements are zero. So we are calling it as a also null matrix or big O or capital O or zero. Next one is called the unity matrix or identity matrix. Unity or unit or identity. What is an identity matrix? It has to be at first a square matrix. It has to be second one a diagonal matrix. Third one condition, it has to be a scalar matrix. Fourth one condition, all the principal diagonals having the value 1 only. So that means look at the thing here. 1 1 1 0 0 0 0 0 0. So the very first one we have one thing, that is 3 cross 3. So that one must be a square matrix. Second one, only the principal diagonals having the value, all the off diagonals are equal to 0. So it is a diagonal element, diagonal matrix. Third one, all the principal diagonals having the same value. So it is also a scalar matrix. And all the principal diagonals having the value only 1. So all are 1 1 1. So that is called a identity matrix or unit matrix. And it is written in the form of capital I. capital I, and according to its order, the order is written in the below as a index. Okay, so that is an identity matrix of order 3. Suppose we have 1 1 0 0, so we may write it as I2. Suppose nothing, only one, the leading element is present, we are calling it as I1 or simply the I. Next, there would be something. Suppose we have a matrix that is 2 2 2 0 0 0 0 0 0. So from the scalar matrix, we can also find the identity matrix. That is, we are not defining now how to multiply a scalar with a matrix. That would be a later discussion. But at that moment, we can write it as like that one 1 1 1 0 0 0 0 0 0. So that means that one is 2I. Suppose we have 3 3 0 0. So it can be written as 3I2. That can be written as 2I3. Now, why that type of matrix where all the principal diagonals having the same value, we are calling it as a scalar. Scalar means that only a value. Okay, that only a value. When we should proceed with the determinant, then we can check the identity matrix have the deterministic value that is only 1. So that would become like 3 cross 1 is equal to 3. Only the scalar is present there. That would be like 2 cross 1 or only 2 is present there. That's why it is also called a scalar matrix. Moreover, only one value, that means that is a identity matrix. Next one term is known as the upper triangular matrix and lower triangular matrix. Upper triangular matrix and lower triangular matrix. Okay. Now, according to the name, just check upper triangular, lower triangular. That means some triangle is present. That type of visualization is present. Let's check what is happening with an example like 1 2 3 4 5 6 0 0 0. Another one 1 2 3 4 5 6 0 0 0. If we consider the principal diagonals, that is the principal diagonal. Now look at another thing. Here, all the off diagonals below the principal diagonals are 0. So according to visualization, we can check an triangle is forming on the upper side from the principal diagonal. That's why it is called as an upper triangular matrix. So for the upper triangular matrix, the off diagonals elements below the principal diagonals have to be equal to 0. Now that is the opposite case for the lower triangular. The principal diagonals are there. So all the off diagonals over the principal diagonal elements are equal to 0. So it is forming a triangle like in the below portion. So that is called the lower triangular matrix. Let's check another example. Here we can say the opposite, that means of diagonals below the principal diagonals are sorry, এটা not
below হবে না তো
upper the principal diagonals are 0. Okay, let's check another example. Suppose we have a matrix like that 1 2 3 0 0 minus 1 0 0 0. What type of matrix is that? If we check the principal diagonals here, that is an upper triangular, because all the off diagonals below the principal diagonals are 0. It may happen that above the principal diagonals, not all the only one element is minus 1, so it may considered as a upper triangular. Same as suppose we have 1 2 minus 3 minus 1 0 0 0 0 0. So here we may check that is also a lower triangular matrix. Now what is happening with that one? Suppose 1 1 1 0 0 0 0 0 0. So what is happening with that one? At first we are considering it as a lower triangular. In the other case, we may also consider it as a upper triangular. For the upper triangular or the lower triangular, when that is the case of upper triangular, that means all the below elements of the principal diagonals have to be equal to 0. Whatever be the upper is. Same as for the lower triangular, the condition is above the principal diagonals, of diagonals have to be equal to 0. Whatever be the values of below the principal diagonals. The main condition is not the below or above. Practically, it is according to the triangle we are forming. Okay, suppose the very first one, 1 cross 1. Suppose 2 cross 2, 1 1 0 1. So obviously that one is nothing. That one is a lower triangular. So what is happening with 1? That is not forming any triangle. Not forming any triangle. So 1 cross 1 is not an upper triangular UT or lower triangular LT matrix. For any matrix for lower or upper triangular, at least order from order 2 it is coming. So it has to be a square matrix except the order 1 starting from 2, and then the condition follows. Next, another one thing is there, that is called the equality of the matrix. Just up to that, the equality of the matrix. What is the meaning of equality of the matrix? Now, equality of the matrix means A is equal to B. So for the equality of the matrix, the two matrices, number one condition, have to be of same order. Number two, the respective elements have to be equal. Okay, suppose we have A is equal to 1 2 3 4 and B is equal to 1 2 3 4. So we may say A is equal to B, otherwise not. Suppose we have 1 2 3 4. In place of that we are writing A is equal to -1 2 3, 4. B is equal to -1, 2, 3, 4. So that is equal. But if we proceed with that, minus in place of -1, we are putting +1 in the matrix B. So we may say A is not equal to B. At least if one positional element value differ from the other, so we cannot say the equality holds between the matrices. Moreover, suppose another matrix is there, that is C. That one is 1, 2, 3, 4. So we may once again say A is equal to B is equal to C also. That is the equality of the matrix. And next, another one type of matrix that is called the idempotent or idempotent, sometimes pronounced as idempotent, sometimes pronounced as idempotent. I am at that moment not giving you the description of how to multiply two matrices, just giving the conception here that the multiplication of two matrices occurring here. Suppose we have a matrix A. Whatever be the matrix A is, if we can find A squared, that means A cross A, multiplication of A with the matrix A. That means we are multiplying the matrix with itself, and we are getting the matrix A itself. After multiplication, then we must say that A is an idempotent matrix. Just giving an example, not the multiplication we are doing at that moment. If we have A is equal to 2 minus 3 minus 5 minus 1 4 5 1 minus 3 minus 4, then if we multiply it with same, that means A 2 minus 3 minus 5 minus 1 4 5 1 minus 3 minus 4, whatever be the resultant matrix we are getting, that is equal to the same 1 minus 3 minus 4. Hence, we must say that A is an idempotent matrix. So yet now the most important terms of the matrices, or that is the which type of matrices are practically required for us, that is rectangular matrix, row matrix, column matrix. Row matrix means vector, column matrix means tuple. Then we have a square matrix, we have diagonal matrix, we have scalar matrix, we have the identity matrix, null matrix or zero matrix, then lower triangular, upper triangular, and finally the idempotent or idempotent matrix, and then the equality of the matrices. Yet now, any question from your side?
Sir,
No, sir.
sir,
বলো।
লো ম্যাট্রিক্স আর কলাম ম্যাট্রিক্সটা একটু বুঝে দেন।
Which one? Row
ভেক্টর আর
matrix
কাপল,
and column matrix.
ভেক্টর আর কাপল যেটা।
Just saying you, asking you. Row matrix means which term is connected with you with the matrix that row. So if any matrix we are representing has only one row, whatever be the column is, that one is called the row matrix. If we have a matrix,
That is the vector also.
that is the vector, right? And whatever be the matrix order is, only we have one column, and whatever be the number of rows, then that matrix is called the column matrix, which is also called as
Couple.
tuple.
Okay.
Okay. Okay, so next we are proceeding with the first operation of matrix. And the first operation of matrix means we are proceeding with that one is called the addition of matrices. Okay, the very first of all, what are the conditions that addition of matrices are possible? Number one, the matrices we are adding or we are going to add have to be the same order. Okay, otherwise addition of matrices fail. Number two, addition of matrices can be done with square matrix and also with rectangular matrix. That's why only the order of the matrix is the thing. Is that rectangular or square does not matter. But the order of the matrices must be same, and same as not only two matrices, we can also add more than two matrices. Let's check what is happening here. In short notation, suppose we have A is equal to Aij M cross N, and we have another matrix B, that is Bij M cross N. So the very first one, order of the matrix same, so addition is possible. Okay, so what is happening here? After the addition A plus B, we are getting Aij plus Bij M cross N. That means the resultant matrix would be also the same order. Let's check with two examples. Suppose the first one matrix is A11, A12, A13, A21, A22, A23. So that is a matrix of order 2 cross 3. That is our A. Plus another one B11, B12, B13, B21, B22, B23. That is our B of order 2 cross 3. So addition is possible, and resultant matrix just according to the position of the elements. A11 that must be added with B11. A11 plus B11. A12 with B12. So A12 plus B12. A13 plus B13. A21 plus B21. A22 plus B22. A23 plus B23. Okay. Now look, the after addition, the order is becoming the same 2 cross 3. Let's check with some digital value. Suppose we have 1, 2, 3, 4, 5, 6. So that is 2 cross 3, that is our A. Plus we are doing minus 1, 2, 3, 4, 5, minus 4. That is our B. So after addition, we are getting like that 1 minus 1. That is happening with 1 to 1, minus 1. Okay. Next one, 2 plus 2. That means happening with the 2 plus 2. Third one, 3 plus 3. That means that is happening with that one. Then 4 plus 4. That is happening with 4 plus 4. Then the next one, 5 plus 5. And the third last one, that is 6 plus minus 4. So the final result would be 0, 4, 6, 8, 10 plus 2. That is also of order 2 plus 3. Now that one was 2 plus 3, that one was also 2 plus 3. So we can proceed. Let us check with another one. Suppose we have 1, 2, 3, 4, 5, 6 plus 1, 3, 5, 2, 4, 6. So that is of order 3 cross 2. That is of order 2 cross 3. That is not possible because that one order are different for A and B. Let's check one from 1 to 1. That is 1 plus 1. 2 plus 3, no problem. Then what to add with 5? There is nothing. Same as 3 to 2, that is 3 plus 2. 4 plus 4, that is right. Then what to add with 6? There is nothing. Then what to add with 5 and 6? There is nothing. So we cannot proceed with that type of addition. Not possible. Okay, that is the simplest thing we can add with the matrix addition. And moreover, if we want, we can also add more than 2 matrices of the same order.